I've never made any pretend statements that I dislike these radios intensely. This was once a President KP77, and these were a Dutch set, and they were officially converted to UK only channels for the 1981 when CB27 81. It's President KP77. I bought 3 of these in this state. There are some cases that all arrived as chassis. I bought these about 15 years ago. I paid £45 for the 3, and they're all guaranteed not to work and were sold for spares only. So nothing was said that they would ever be repairable. And the biggest problem I have found, although I've had some that work, is that you can end up with the VCO not locking because when these were originally manufactured, it was for the 22 channel PTT system, and I think that by putting the 40 channel UK board in, and so this was an official modified set, there's nothing dodgy about it, I just feel that it's overstretched what the VCO could sometimes do. But you know, we've had some luck by changing capacitors on Uniden sets. Now they're 38 years old, and these will be a little bit older, they might be 40 years old. I think there was a warehouse full of these, and the Dutch system went over to 40 channel, and you know, these 22 channel sets were probably sat there lurking. So the plan today is to see if we can get this to work, and we're going to change some of the capacitors I expect to fail, and we may end up changing all of them. So I don't like these, and at the end we do have one of these in full working order, which I've done previously, and at the end of this will be put on eBay. Now the cost of doing this, if everything goes swimmingly, this will then stand me at about 50 quid. Whatever it costs, it's starting price on eBay. And we'll have put a mic to it, which will be another £15. We'll have put a case to it, and those cases have had to be bought in. So I don't know. So what starts off at £15 in a box of tat can soon build up to 90. So we've got the expanded for the 40 channels, we've got the amplifier for 4 watts, because I think there'd be 2 watts or half a watt. One of the problems was 220 volts mains transformer, and we're 230. At the time we were 240. I'm now not bothered because 230 and 220 isn't that far apart, but I used to be bothered when it was 240 to 220. I've not had any problems, but it does mean the capacitors can be easily overrun, and we'll be changing those as a matter of course. We'll be changing anything which is 220 and anything that's 470, so it's probably those. So that's what we're going to be doing. Now I'm going to start this video. We're going to go over to my camcorder shortly, because this radio is going through the dishwasher because it is filthy. And in fact, as soon as I've taken it apart, I've already run the bath, because that's what I'm jumping in. I do not like things, I don't like the radios anyway, but I certainly don't like ones which look like where coronavirus started. So we're just going to pause the video and we'll take the knobs off, and no, we won't pause the video. We'll try and unscrew them in situ. Now, where's my favourite screwdriver? I've got the that one will do. So I'll see if we can pull these knobs off without me. That's one. Have we got a little receptacle somewhere? Looks like we haven't. Yes, we have. It's up there. These will be going in the dishwasher as well. Those will come off. So we'll just unscrew. Now the case we've got once belonged to an audio line base station, the case top, and it's full of holes for those cat call system things where all push buttons once lurked. So it's going to have either a row of holes or a row of push buttons, but you know, at least it's a case, isn't it? And actually I was given that case top, but of course I had to pay the postage, so I think it cost me $7.50. I wonder when this last worked. I wonder if it ever will work. So why am I taking the case front off? Well, I'm taking the case. Oh yeah, I forgot about that. The LED. There we go. Of course, that is absolutely filthy. That's one dishwasher item. But the whole radio is going in the dishwasher. And what we're going to do then is we're going to put it on a wire mesh in Mr. Chippy's workshop with a convector heater on low and with the air conditioning on. So what we're doing is exciting the water molecules, which will be left by the dishwashing process, with the heater, and then we're dehumidifying with the air conditioner. And this will probably be something which we can start working on later today, because it will be sufficiently dry. And at the end of the day, if it was a flawed decision, well, it's my set, isn't it? The worst case scenario is we have to change that mains transformer, but we've got them in stock, but again, you know, we're looking at £15 to £17. So we don't want to make this into £130 cost price. So we're taking the speaker out. I better put the soldering iron on, because obviously I don't want a loudspeaker through the dishwasher. Not easy to get to the screws on this angle. I'm actually going to have to use my little black tool there. There we go. So unsolder that in a moment. Now we need to take the meter out. I'll show you what I've done in a moment. Mind you, we took the meter out of one of these the other day, but it was a Unit M300, wasn't it? And very nice it turned out too. And this has put me off President radios for life. We've had some new ones which work quite well, I must admit. That Randy Hand Portable is one of them. We've also had some mobiles that aren't that brilliant. Oh sugar, the front's come away because the tape's failed. That isn't good. So we'll unsolder the connection wires. Now black was positive on the last one. And black is positive once again. So we'll now recover the front of the meter, which has come untaped. Well, we'll take the opportunity to put the front through the dishwasher, and we'll keep the meter movement very carefully without its front on. That's a fair enough opportunity. Take out this speaker, and white is positive. So on the meter, black is positive. On the speaker, white is positive. You'll all remember that. So the speakers come out and looks nice. No cone rubbing or anything. So I think this is now a safe candidate to put through the Tango Towers dishwasher. I'm not going to have a capacitor that shape. This may be in several parts because it'd be fun for people to see what we're doing, and I may have to wait for parts. So we'll see what happens, and we'll go over to my kitchen. So as you can see, we have the bottom tray with the front, and the little cutlery thing has the meter plastic bit and the knobs. So in the top we have the radio, and that is placed so that it's printed circuit board top upwards. The idea is that I don't actually want to get lots of water getting into the coils or the transformer, so it's going to be able to drain out. And then, as I say, we'll put it into the next room, and we'll dry it in a well thought out way. So here we go. We're deliberately running it with no finisher in or salt in. We are on a treatment system here for the water, so it's putting in, because it's a hard water area, so there's an external water softener, and we're deliberately not putting anything like that in because it can affect anything that's aluminium. So I have put a dishwasher tablet in. We're on a small load. We're on the what temperature wash. It's the smallest one, isn't it? Number 2. 35 degrees. We're not boiling it, and here goes. Good, so we'll come back to that in a bit. And now it's exciting time. Oh, that looks a bit better. Yes. And if that's on the right camera angle, it's lost its escutcheon. Which is there. And they're a bit better too. And the one which fell on the floor. So Mr. Chippy's workshop, this back room, we've got one of those convector heaters, and this one has got a digital temperature thing and remote control. I think it came from Lidl. Where else would I shop? And what we've got is a wire basket which originated from a chip pan, a new chip pan, not an old one. And that, just move that camera down, I'm using as a spacer. So I get that chassis. And that is now a spacer, because obviously we don't want to be covering a heater like that. Now, the clever bit is here. Would be if the camera reached far back. Yeah, right. We'll change the tripod angle. There is the room's air conditioner. Switch that on. That's set. I'll tell you what, we'll change the temperature to 21, so it's going to be on more than it's off. And then we'll come back to this in about 4 hours. Okay, so roll on about, actually about 6 hours later, and we've got a clean radio and a dry radio, hopefully. We'll be powering it from 12 volts and not the mains, because the radio may not be worth spending any money on, and I don't have to spend money on changing capacitors unless it's already looks like it's promising. Now, because it's had moisture underneath, we now have all this horribleness. So we need to use the isopropyl alcohol, which there is one here. Where's Mr. Chippy's toothbrush? Oh yes, there it is. I've never seen one go as bad as this before. There's a printed circuit board just there, which carries the connectors, I think. And I may as well do the power supply one, just in case we get it working enough to do this. Good. I've got that board there. To be honest, I'm not expecting that to have happened to that board. I've just touched the underside of it and I don't see any. As an experiment, I wonder if it's easy to take out. We're not going to put the speaker back, we're not going to put the meter back unless this radio is something like working. these nuts and bolts. Yeah. No, I don't think they're affected at all. If it doesn't work, that's something to look at. But I'm not. I can see from this side that there's no nastiness. These are better washed boards than the original. No pun intended, having just washed the radio. So there's a little bit on the back of the display board. Right, with the crocodile clip leads. We'll power it up. And we have a full short circuit. Now, what's it's not that. Something else on the bench. That's it. It's gone away. Okay, so we've got a meter light. We've got a display. Channel 20. I meant to take those push buttons off, but they've come up anyway. We'll start by seeing whether it works in public address mode, and that way we're testing some of the audio circuits. So I'll put the isopropyl alcohol away for now. Now we should have a unit end mic on here, because we were doing a unit end the other day. We need to switch this to public address. Turn down the mic gain. Oh, something. Is it volume? Where is that? Oh, it's the it's that one. Testing 1 2. Testing 1 2 3 4 5 5 4 3 2 1. I can hear a bit of distortion there, and that leads me straight away to those capacitors. Good, so it's working in public address mode. So we'll swap that over now to extension speaker. And we have an FM hiss. Again, I don't think it sounds good. That again will be those. I haven't changed the volume, but it is changing. Right, signal generator, channel 20. We were last on 2 meters, so I better just take us quite a way. We've got nothing on receive, so we've got transmit. And we've got nothing on transmit. So let's see whether the synthesizer is actually doing anything. Turn the signal generator down. No. So that's as predictable as ever. Right, so next day, go through some of the logic with this. Not getting anywhere because if we connect the red wire to the synthesizer, it shorts out somehow it seems to short out the 8-volt rail. And I looked at another one of these and that's the same. So I popped out the synthesizer board to make sure there was no nastiness underneath from its wash. So I don't know what happens now if we connect that red wire. Oh, that's fine now. Yeah, so because it was out of lock, this was sending a signal to the 8-volt rail and shutting it down, it seems. But rather than inhibit the transmit, it was inhibiting receive as well. So I've got the oscilloscope out, this one, and there was nothing on the crystal. So if we look at pin 11 or 12, I don't know which one's the active crystal one, let's try 12, 10.24, that wasn't there. Now, of course, with it being a modified set, you're never sure what should be in the radio and what shouldn't be. I mean, like any CB radio, there are extra holes for other areas, other models. So what I did was because I couldn't never remember all the ins and outs of the synthesizer, I photocopied the TRC 1001 page from the service manual, which gives the pinout and description of the phase lock loop chip, the 7137. So pin 14 was causing us the shenanigans. I thought, well, if it's out of lock, I thought, first of all, we'll check this crystal in on pins 11 and 12. There was nothing. So I look at the radio, put my oscilloscope on the crystal, and I've got 10.24. Then I went to the trouble, and this took some researching. Turns out, I think it's a President Charlie in its 22.5 watt original state. So forgetting the synthesizer, which is 22 channels for the PTT system in 1980. Yeah, these were made in 1980 and then modified in 81. When we look at the crystal is shown there. You've got capacitor 76, which is 56 picofarads. Now when we look at the KP77, this bit of the circuit, the photocopy of the photocopy of the scan of the photocopy isn't clear just there. We can see the capacitor but we can't see what it reads. So it is supposed to be in. So compare it now to the how it was originally made with the TC9119. It says it's 56 picofarads. That one, capacitor 76. So, capacitor 76, because we've now got a layout, which was one of our stumbling blocks. We've got wiring and we've got a layout. So we can see on the layout, and I could see with the... Where have I put my probe? I used that one. So that capacitor is 76. It was missing. Now as soon as I've put that back in and turned back on, I'm on channel 20, good receive. Now, I haven't gone down the transmit avenue yet because... Where's my... and I dropped the ceramic tool on the floor. So I hope I didn't break it. So I think we can take the oscilloscope away once again for a short period of time. Traditionally we do diagnostics on the bench behind me, and that has a gold star oscilloscope with on-screen displays, but I'm on this bench, there's no video equipment on the other, so that's why we're using the take-out of the oscilloscope. Where's the trimming tool gone? Oh, it's there. Thank goodness it hasn't broken. So without knowing the setup, now there may be other faults that are stopping it from locking. Just get the little handheld out, might help hear it. Take the squelch off. Oh, you can't do that easily. Might have to use a different one. I don't know how this works. This is the trouble with these things. If they're not self-explanatory, we'll hold that and the mic. Right. So now it's locked. Testing 1, 2. It's not transmitting, but it's locked. So there'll be another fault which is part of that. So now we'll put the lock detector wire back on. Now this was disconnected on this set. You just do not know what's happened to these in the past. You know, when you buy them as scrap, that's what they quite possibly are. So let's see what happens now. So we are still transmitting 1, 2, 1, 2, but we're not transmitting any power. But we do know that the VCO is generating the frequency, so it'll be something hopefully quite straightforward, and that's something we'll look into this afternoon. I'm going to go for lunch, and we're actually getting somewhere. So I've got the Russian probe out. There's trouble with base stations, they take up so much room. See whether we can move the camera a bit. Probably better. So I'm going to the this is the original part of the circuit to all intents and purposes. It's just got that add-on amplifier. So we don't know why was that capacitor robbed. Well, somebody might have been short of a 56 picofarad capacitor because the radio didn't work. So, you know, we kind of a bit of a mystery, isn't it? So test point 2 is there, which is to the driver. So have a look at that. Test point 2 is quite clearly labelled there. Press transmit. Oh yeah, we've got plenty of RF there. So now we'll look at test point 3, which is that link there. We've got nothing. Oh, we have. We've got less there than we had before. So to be honest, it looks like the driver transistor isn't working. And there's the logic. If we've got it there at the base, now of course the coil could be open circuit. Actually, test point 3 is would be. No, test point 3 isn't the place we want to be. We want to be on the base, so we want to be the far side of resistor 37. So resistor 37 could be there. Oops, I think we've knocked the power off. Really, I need to scrape away some of that insulation. This might not be the tool to do it. Just put the probe on there. There's nothing there. I think it's time to take some transistors out, so kill the power, pause the video. So having worked my way through the transmitter, I've checked the pre-driver and that works. So we'll now check the driver transistor, especially if I get the prods on there. Yep, and that's testing out as a transistor. I'm going to power it up without that in and just see whether we get an increase of voltage or whether we don't. Let's have a look. So we're powered back up, we're supposed to be powered back up. If I hadn't knocked my crocodile clip off. So, base of the pre-driver finds the mic. I was wondering whether it's being dragged down, but it isn't. It's not being generated in the first place. I'm not quite understanding why that is. Pause the video. Okay, so taking those out, putting them back in. Although the pre-driver transistor read alright, I've changed it for one off a scrap chassis, and we now do have. We did have the mics come out, transmit. So see whether we can tune that up. Right, we'll go for picture in picture. Can't see where the picture is. Oh yes, it's there. So we have 1.5 watts. Don't expect more than 3 watts out of these. I've had the odd one do 4, but bear in mind they were half-watt sets converted. The output transistor added on the subboard is a 2SC2166, so that makes that more valuable than the whole radio. That's 3 watts. And that's where we are, 3 watts. Now wouldn't you think that this didn't need tuning, because surely it just broke down and needs repairing, but no, it's clearly had finger problems. And then we've finally got one there, which I'll now deal with. Don't know whether I can do it with this tool. No. So I'll put away the diode probe, which is now in the way, or the RF millivolt meter. I'm not even sure what's in there. No, 3 watts it says. Well, that's got us quite some way. Now, of course, whether it works on any other channels is another matter. Oh yeah, of course it's going to be on frequency, isn't it? That's par for the course. And I don't expect it's adjustable. No, it's not adjustable. So it looks like we may have to change the reference crystal, because that's too far out of spec, I think. Just change cameras. Sure, we should be on 2779125. 791, that is too far out. Right, we'll unpower it. Not sure where my handy crystal tester is. I think it's on Mr. Chippy's bench, but just for now, we'll see whether we can do better straight away. As long as we're in spec, I'm not that bothered. Right, I'll put the power supply back on. That's no improvement at all. Right, I'm going to worry about the frequency problem in a bit. We'll carry on with the radio as a radio. Let's have a look at the deviation. Wallow. 1 2 1 2 1 2 1 2 testing. Wallow. So that's pretty quiet. So I'll look at my notes. I've done 2 of these before. I selected this one as being the worst. So deviation is there. Oh, they're actually labelled. Wallow. There we go. Spot on. That was way out. And we'll put the meter back when the thing's actually working, I think. Yeah, it saves damaging it. So we'll move on to the receiver, and as you can hear, it is receiving. I'd better take my signal generator off frequency. Otherwise, what I do may be wrong. So 78888. There we are. That's what we'll put in. 2778. It actually sounds quite good. I'll put the oscilloscope on, and we'll put the cyanide meter on, and let's go over to the oscilloscope's camera. We're going to put an S9 equivalent on the signal generator. And as ever, it's just across the speaker. There's nothing special about it. And we'll adjust what is going to be the detector coil. I don't think I even need to look at my notes because it's going to be that one. Spot on. Let's go over to the cyanide meter and see what it's actually doing. So right now it's doing 0.78 microvolts, which is fine for 12 decibel cyanide. Lots of new sets don't work as well as that. So we'll run down the RX. So we'll set the cyanide meter to about 4 or 5 dBs and let's go for it. Coil 1. Some improvement. Coil 2. Already spot on. Let's drop the attenuator. Coil 3. Coil 4. No adjustment necessary. Let's go to these IF ones, put a bit more signal on. Slight improvement there. Drop the signal fraction. Go for that one. Spot on. So it's, you know, receive not messed with. I might be changing those capacitors yet. Well, that was very easy and we've got a good result. So let's see what that result now is. So it's 0.78 before and it's now 0.67. So we've gained a little bit there. I'm not expecting you'll ever get less than 0.5 on these because of them being a conversion. They were expecting a slightly lower frequency, and we're doing this on channel 20. But remember, we've tuned the signal generator to the radio, which is off frequency, so the receiver is spot on. If we'd have tuned it to the proper frequency and the radio was off frequency, we may have ended up with these IFs being wrong. So that's all sorted. We can't do the S meter, but we can do the squelch. So squelch to full, and we'll park the signal generator. No, we won't. We'll advance the signal generator. I want the squelch to come in when I get to 100 microvolts. So let's put the attenuator on here and drop the ceramic tools on the ceramic floor. Right, here goes. 3, 10, 30, 100. Where is it? Not there. Comes in at 10 millivolts. That's no good to me. Might be easier to see what my notes say than what. Yes, it's that one there. I want to pop the squelch to a position where the squelch now opens. If there is a point at which it ever does. The answer is no, not how I want it to be. Let's pop it up a fraction and go to both ends of the scale. No, pop it up another one, go to both ends of the scale. And another one. It's there. So that's minimum. It's not ideal. It's 2 millivolts. So we'll drop that down, take the squelch down to minimum, turn the signal generator to standby, and then set threshold. Switch the signal generator on, and let's see when it comes in. Once again, it's pretty lousy. 7.5, 8 microvolts. See if I can set my squelch on the radio that little bit more carefully. And try it once again. That's better. It's coming in at 1.4 microvolts and going out at 1.2. So, not the most sensitive squelch in the world, but I don't think the unit ends are brilliant on that kind of sensitivity. In fact, actually, this is working more sensitively, I think, than some of the ones made for the UK from Unidem. So that's actually done. So we would have found a way of making this thing go spot on frequency. I've tried 3 different crystals and they're all off frequency, so it tells us that something's drifted in the electronics. So I think we're going to be looking at. I changed the. This makes me wonder: was that 56 picofarad capacitor removed because another engineer thought, well, I'll tell you what, we'll change that for a different value to make it go on frequency. So I think that's where it's got abandoned, and that's why it was missing. So that's something we're going to sort out. But it's nice to see it doing 83 watts. We're going to work on this power supply, and I will probably continue the video. It depends how we do with time. Here goes. We'll go to standby. Okay, we've got it on frequency. I've changed the capacitor, which was 56 picofarads, for 30 picofarads by trial and error. Now we've got it slightly high, which is better than a long way low, 797917. So that's well within spec, and it's got room to drop. So it's frustrating they don't put an adjustment in these, because it would make all the difference. So really, perhaps it would be even closer if we put something like 33 picofarads in, but that's not one we have at the moment. But anyway, that's definitely close enough. So we're still doing, we're doing 3.4 watts when cold. So there we go. Right, I'll put the meter back. Right, so now we will look at putting the radio back on with the meter. So the meter light's lit. I'll put it in upside down. Oh, that was clever. Start again. As I was saying, before putting the meter in upside down. Right, now we can set the S meter I'll unplug the extension speaker now, so that's the built-in speaker. So we want an S9 signal. Need to make sure the frequency of the signal generator is now correct because the radio is now correct. So that is S9 and it's showing us as coming the power off again. I'm not going to be able to prop this up and show you, am I? I'll make the adjustment and then we'll prop it up in a moment. So the S meter is that one. And the RF meter is that one. Pegging it. You know what I reckon, because it's a half-watt radio, I don't think they've taken into consideration that that is expecting half a watt. I'm going to turn the power supply down to about 11.7 volts, if it still transmits at that. It does, it now does about 2 watts. So I'll just see whether I can adjust. I just want it to be at the least sensitive end. Yeah, that it will always peg across. Not good. But just to show you, we've got an S meter now reading S something or other. Hopefully you saw that, S9. So I may as well put the front on and we'll start on that power supply. Obviously I've got to put a mains lead on it, which is chopped off, and change the capacitors in the power supply. There's one underneath as well. I'll may not change that. I'll test it and then we'll see whether it will run on its own steam. But it's quite something, quite an achievement to get this back in any working order at all. Okay, so we've now got the power supply on. We're at 13.7 volts. Let's just pop that up to a little bit more because it's a bit low on output, isn't it? So we'll have it at 13.9. So that's with new capacitors in the power supply. And I'm satisfied that's the voltage. So let's see what happens when we press transmit. It goes without saying I've put a mains lead on this. Better remember to plug the aerial in. So the set's now cold. It's been 2 or 3 hours. Did another church service in between. So we'll switch this to there and put picture in picture on. And hopefully we're on the 30 watt range on here. So there's 5 watts, that's 4 watts. So I'll key up now. About 3.8 watts of cold. Good. suppose we ought to just keep an eye on that voltage as well. I'll key up 13.88, so it is sourcing that power okay. Now these aren't shrouded like newer sets are, so they're nothing like a safe. So there's main terminals all over the place, the front panel there underneath. So they're not like the later ones made for the UK. Okay, what I'm now going to do is change both those electrolytic capacitors. So I'll switch this off. This is just a precautionary thing. I'm not changing every capacitor in it because not everything's playing up. But when the VCO was playing up, I did change them all in the VCO section. What's 220 microfarads in a lot of later sets is 100 microfarads here, so that one and that one were automatically replaced. I think the audio is slightly harsh, and we'll just change those as a matter of course. So that's it, electronics done, all working. I'm going to just put some switch cleaner on the controls, and then I think we have got a bottom. We're going to put the front panel back on. There it is. I'll have to glue this escutcheon back on, and still not the shiniest one you've ever seen, but there you go. Right, so it's now got a bottom on it. That front's now back on, but it needs the escutcheon putting on. Now what lids we have, these sets didn't come with any case parts. They all have the fronts, but the three sets, they didn't have lids or bottoms. And over the last 15 years since I bought these, I have procured better than nothing case parts, shall we say. And I think we've got one for this, and it's covered in switches, which I probably mentioned at the beginning of the video. Right, well, we've put the case screws in the top and the edge there, and I haven't got any side case screws. They're M5. I'll get some ordered. But apart from that, we've got a lid on it. So, don't know whether you can see. I better zoom out a bit. So you've got this bank of switches from a cell core system. It must have been an audio line 345 or a Unit M base station that somebody scrapped, and they gave me the lid and I just paid the postage. And I had the bottom as well, so that's why we've got the bottom on it. And I just paid him the postage, which I think was £7.50. So all that remains for us to do, try not to put it on the aerial plug. We're now on the aerial. One none, Roger. I'll just go and get the screws in the knobs. You know what I've done? I've not got the TX Aerox light pushing through. Forgot to put the LED, it's a dual colour LED in. So when I get the case screws, I'll just whip the top off and put that in. So that's today's error, or this weekend's error. Spent 2 90-minute sessions on this, which is cost prohibitive, but I just did it as a demonstration. We've got 2 more of these, as I say. But when I've looked at one of them, it's actually had the innards changed, and it's no longer a KP77. It's now got something else in its place. I think it's a Uniden. So it's a difficult legal situation, because although they're both legal radios, yeah, can't really take it out one case and put it in another. So we'll see. Now I've just cleaned this with foam cleanser, so I'm not going to glue it back on yet. We'll be using Bostik adhesive. And there's the KP77 done. So we'll do it on the air test later on. And there you are, a scrap KP77 chassis. And I'm as shocked as you are that I've actually managed to turn into a working CB radio. Thanks for watching.